A very good evening to all, and I am Biju George, and on behalf of the Southeast England and London branch of our institute, I would like to welcome you all to our today's event. Today we have with us Jan Brugger, who is a co-founder, Chief Operating Officer and General Manager of FuelSave, Germany. And Jan will be discussing with us on the topic, the next generation efficiency enhancement for maritime vessels. A few words about Jan. Jan holds a graduate degree in business management and a BA in business administration. He began his career in 2001 as head of sales in telecommunications for Media Market, the consumer electronics retailer. Jan then moved to the automotive industry, where he worked for several companies as CFO and CEO, before becoming CFO and later shareholder and CEO of Inform, an automotive service company working for BMW, Mercedes, Audi and Volkswagen, providing highly skilled and rare specialties in Europe on demand. In 2014, Jan sold his Inform stock and co-founded FuelSave together with his colleagues Dirk Hoffman and Mark Zimmer to focus on clean technology and energy efficiency enhancement ventures in various variety of sectors. He seed funded part of the risk capital for FuelSave to develop its prototypes, deploy pilots, test systems and register patents in a variety of sectors. Let's welcome Jan to deliver the presentation. This presentation will be a three-part presentation. So Jan will be giving a 50-minute talk, then we'll raise the questions, any questions on that, around a few minutes, then go for the second one, then third. So three-part. All right.
Thank you, Biju, for the kind introduction.
All right.
As you heard, my name is Jan, and thank you very much for the opportunity today to present our solution in front of such highly qualified audience. I've been on many fairs. Of course, we had a lot of contact with end customers, and so for me it's really a pleasure to present here. What I have to admit in the beginning, as Biju said, I'm not a technician. Okay, I'm not an engineer. Normally, scheduled was our technical director for this presentation, but I'm going to try my best to answer all the questions. So today it's about FS Marine Plus. It's our solution for the shipping business, because FuelSave itself is a company developing several technologies for several applications, but today of course it's about the application on marine engines. Saving energy is our main goal for every technology that we develop. So we are really committed efficiency technologists, and we try to improve several processes in the energy balance. Because in the end, saving money is all about what customers care, especially in the shipping business, we all know it. Saving money is the key to selling solutions that can make a difference in the end. Because you can have the greenest product, we know many products in the market that are green but not economical. And if they are not economic, you won't get the chance to sell them, and the products itself won't get the chance to do something good, also for the environment. So we try to do our part to save the planet. The table of content it's a very long content. I'll try to stay within the time budget, and I'll go over some things maybe a little bit more quick than others. So this is a brief overview. The application consists of a hydrogen generator in combination with a methanol water injection. So we reduce fuel consumption by 10 to 15%. That is a net value. Okay, I'll go into the net value calculation later on, more in detail. We reduce emissions drastically, but you'll get figures later on. We also reduce engine wear and tear, and of course increase the operational profits of our customers. That's the reason for them to buy it. Because shipping companies are green, of course, they like to be green, but they won't pay for being green. So it's all about economic aspects. Yeah, our vision is to become a leading supplier for efficiency technology retrofits and to establish a sustainable solution that has a clear economic and ecologic benefit for the customer and of course then for us all. The solution itself can be retrofitted, which is very important to know, because for us we wanted to create a solution that is available today. Because we have a fleet of 55 to 60,000 vessels, numbers are some kind different, but that's the range we talk about. And we need retrofit solutions that pay for themselves. Otherwise we're not able to do anything about the existing fleet. Because every new build ship is a measure that will take its part in 5 years, but not today. Of course, shipping is very important. It's the backbone of global trade. I think I don't have to tell you that. So, and we have to reduce CO2 emissions, of course, due to regulations, and ships have to become more efficient. So that's the regulatory drivers and background. I'll talk a bit about the global sulfur cap, just from an economic point of view. Of course, you know all what it's about. And current studies, or all studies, show that in 2050 we will still be dependent in shipping or in every industry on fossil fuels, meaning heavy fuel will still be a part of it. So we need solutions that tackle the problem of fossil fuel consumption in shipping today, but also in 20 or 30 years. So what problems are we addressing? Of course, it's fuel costs. I mean, we've seen it in the last month. Fuel costs are still rising, which is good for us because our business case at the moment gets better every day. We have the climate change, global warming, and of course air pollution, which is one of the biggest, maybe even underrated problems to general health all over the world. Of course, burning fossil fuel is not a solution to anything. So we want to tackle the problems today, at least improve the consumption or the use of fossil fuels on marine engines today. So the solution itself generates hydrogen on demand. That's very important, and I go more into detail later on. And it injects the hydrogen and oxygen together with water methanol into the air intake of the engine, in different parts of the engine. This most likely will raise more questions, more technical questions from your side later on. The effect is that we improve the ignition and the combustion process. That leads to a more compound ignition process and to a cooler and more efficient and cleaner combustion process in total. It's the world's first approved solution in that regard, that DNVGL as class has given us a testing approval for the first time, and also for the second time the testing approval has been prolonged. It's of course patented. That's the capital we have beside the solution. Patented in over 40 countries now. And in the last year, end of last year, we received a EU funding from the Horizon 2020 program, which is very hard to acquire. Maybe, some people here know that. And so the interest also from EU side is generated and valid. So how does the solution work? As I said, we inject hydrogen and oxygen. The gas is generated via an electrolyzer, a quite efficient electrolyzer, because of course we want to have a very good energy balance. And at that point I have to make clear that we not replace fuel by hydrogen. That's one of the questions we normally receive. That wouldn't make much sense. I mean, everybody of you knows, of course, if you generate hydrogen by power generated from the engine, and we feed that hydrogen back into the engine, it wouldn't make much sense. And we only use very small amounts of hydrogen. It's about 0.1% of the air volume that is going through the air intake to the engine to already create very positive effects. The hydrogen and oxygen is supported by a methanol water injection into the hottest part of the air intake behind the turbocharger, and by that we cool down the air intake temperature. But I'll go more into detail on that later on. That's what the containerized solution looks like, but you'll get an impression on that in the video later on. Of course, the unit, the whole system has to be integrated into the ship's network, into the alarm system, ventilation system, freshwater system, and the methanol storage system. That's what you see on the left side. In the middle is the different parts of the system. We have the security control, or the PLC control, that is controlling all the processes of generation of the gas, of injection of the liquid, and the mixture of it. There's also a demineralization unit integrated, because for the electrolyzer we need very clean water. There's for sure a technical better phrase for that, but we need very clean water for that electrolyzer. We have a small intermediate tank where the methanol and the water are mixed. Right now we are operating with a mixture of 30% methanol and 70% water. And that is injected via a high performance injection pump into the air intake. So the gas component, the hydrogen and the oxygen, are given into the air intake passive, meaning we're going to somewhere near the filter system, where we have a low under pressure. So that is, the engine takes it in itself, while the liquid has to be injected, because we are in a pressure bearing part of the air intake system. We did a field testing with a Hamburg shipping company, a very renowned company, at least in its segment, is SAL Heavy Lift company from Hamburg. And we installed the prototype in the end of 2015 and got the approval in the beginning of 2018, and the unit has now been running for over 2 years, almost 2.5 years, with the approval of the DNVGL. And we had very positive results on that, but I'll give you many more figures later on the results. Yeah, that is MV Annette. That's a ship where the solution was installed. And it was operated there in automatic mode, so it was running on its own, and we had almost no problems. We had to exchange 2 valves, but it went very good. Our expectations, even our own, were a little bit more pessimistic, but the prototype went really well, what convinced us and all the stakeholders to go on with the system. We had, the system was installed on an auxiliary setup there, on a Volvo Penta auxiliary engine, and depending on load level and operating conditions of the engine, we had up to 16% net savings in fuel, meaning that we had larger gross savings of up to 25% on part load level on that engine. And net savings in this case means really financial net savings, meaning that we've taken into account, of course, the consumption of methanol, the consumption of power, even we balanced the consumption of water. So all operating materials were taken into account. And we had really great results to go on. The solution was also tested, the working principle, not the system itself, but the working principle of using hydrogen, oxygen, water, methanol on a combustion engine was tested at the University of Rostock. They have their own institute for the industry, which is called FVTR. It's quite renowned in Europe. It's one of the marine centers in Germany. So the bigger engine manufacturers like MAK, MAN are testing their oil additives or injection systems there. So we went there and had our working principle of the solution also approved and validated. So the biggest benefits for our customers are, of course, the fuel savings. In the end, it's about money, and we can contractually guarantee 10% OPEX savings. That is where we are positioned now, and where we create the interest on the customer side. So as we have very good results on different applications, not only on ship engines, but also on truck engines and even on biogas plants, we can guarantee the customer the ROI. This is a brief overview of the net savings and the emission reduction potential that we have with the solution. So we have already spoken about the net fuel savings, up to 15%. We have SOx reduction, of course, in the same amount as we reduce the fossil fuel. So this is 10%, and by replacing a little part in the energy balance of the fossil fuel, HFO or MGO, by methanol, we can reduce the SOx by up to 20%. Of course, this is not enough to meet the requirements for Tier 3 or to replace the scrubber, but it's a good value for itself. Where we are really tremendously good is at reducing NOx emissions. We can achieve up to 80% of NOx reduction. Of course, this is a positive benefit from the cooling down the air intake temperature. But these values have also been validated at the laboratory at the University of Rostock. And what is very important, that we reduce the black carbon or the filter smoke number. In Rostock it was the filter smoke number. We reduce the particle mass up to 40%. And as you all know, particles are one of the most dangerous or unhealthy or even poisonous air pollutant there is. Okay, the total potential of CO equivalent reduction for the shipping business would be 9.7% if we installed it on every vessel there is. So this is just a figure to keep in mind. You all know the Sulfur Cap 2020. I'll go through this quickly because it's more related now on the customer side. But as we know, you don't have many options to meet the requirements. Either you buy a scrubber or you use low sulfur fuel oil. These are the two options you have, or you just do nothing and wait what happens. Actually, yesterday I've been on the tanker and shipping conference, and many people lay back and just wait and see what happens to 2020, because there's a big uncertainty about prices. Nobody knows the fuel prices, and so not too much is happening there. And also everybody knows scrubber has a tendency to increase even fuel consumption. So it's not an economic solution in the first part. It has also many costs and maintenance costs later on. For us, for our solution, it doesn't matter which way the customers go, because we already start at that point where the costs are created, and that is the consumption of fuel itself. So if you use HFO with the scrubber or distillate fuel or low sulfur fuel, our solution works with any kind of fuel, any kind of liquid fuel. We even have positive effects on LNG engines, especially in the reduction of the methane slip. Everybody of you knows that the methane slip is also one of the biggest unhealthy factors regarding LNG. From my personal point of view, that's the reason why LNG cannot be part of the solution for shipping in the future. So, scrubbers scrubbers can benefit actually from our solution, especially this is an open loop scrubber. I mean, we all know what an open loop scrubber is. If we go for closed loop scrubbers, of course, if we reduce the amount of exhaust gas and the amount of emissions that have to be cleaned by the scrubber, then we could reduce the wastewater treatment unit and could make a scrubber less expensive, could make it a little bit smaller, and in that regard have a better ROI if you anyway have to plan to invest in a scrubber. So our solution is always complementary with any other efficiency solution. Okay, as I think we have to speed a little bit up for the first part. So it's just what I said. A scrubber costs money, and the return on money is uncertain because you don't know what happens to the fuel prices in the future. While an investment in our solution always, you can guarantee an ROI, and so there's no uncertainty no matter which way you go in the future. In general, only one sentence from that, we tackle the problem. The generation of the emissions and the fuel consumption at the combustion already. Every system else is just a treatment of the symptoms. Actually, to be honest, maybe I skipped the video. It's fine. So I think we're now in the question round for this first part.
Any questions, please?
There's none through from the live stream at the moment. There's normally about a 30-second delay, so if we maybe move to the group here first and then...
Yeah, is the plant scalable? So if you've got a smaller vessel with smaller plant on board, how small can you get it? Because I'm looking at this your payback opportunity.
Yeah. Actually, we even designed a solution that is fitting the needs of inland vessels. So actually, but of course, for high-sea vessels, when you take into regard the approval costs, maybe it's 1 megawatt is the minimum size, I would say.
Okay.
Where you have an economic case, a business case. But it depends more on the operation profile of the ship. When you have a liner that is running all the time, you have high fuel costs, you have high fuel consumption, then you easily have a very good business case with the solution. If you have heavy crane lift ships that sometimes only are operated 6 months per year, then it's different. So I wouldn't make it. I wouldn't point it to the size of the engine. It's more depending on the operation profile.
Okay.
And the total fuel consumption per year.
So what is the average cost to install on, say,
Yeah.
a medium-range tanker?
What is the engine size of an?
I mean,
What would you suppose? 10 megawatt, 15?
I mean, if you look at say a normal manned DW
Yeah.
engine with I don't know 10,000
Okay.
micro.
HP.
We have a rule of thumb.
Yeah.
For the moment, we calculate about 80. Now depends on really on the size of the ship. We calculate between 60 and 120 euros per kilowatt engine power.
Okay.
But we always design the solution to the operating profile of the engine. Because when we have 10 megawatt total power, normally the engines are operated somewhere between 40 and 70, 75, 80%. So we design the unit to feed the normal operation point of the engine. It doesn't make sense to build a system for 10 megawatt if 10 megawatt is never used. So then the prices also depends on the operation profile of the engine. Because we always provide the amount of gas or liquid injection needed for the load of the engine.
So what's the biggest engine power that a single container unit can be able to supply?
Actually, if we go for the container solution right now, the pilot project and the prototype project have been individual installations inside the ship, the security department and methanol department. But if you take a look at the container solution, the hardware we need actually fits into one 20-foot container. Okay, the rest is only about the methanol storage. And the methanol storage, it's a typical question. We calculate about 5% of the total fuel consumption of the ship, or the average fuel consumption, we calculate in methanol consumption. So if your ship or one of the tanks is refurbished, redesigned as a methanol storage, then it's about 5% of the bunker volume.
Okay.
That's about what we calculate. But the hardware itself is not much. You're going to see a picture of the prototype later on for the auxiliary engine. It's only half an oil pallet. It's very small.
Any more questions?
None from the live stream at the moment.
Okay, then we go quickly on to the second part. Maybe the third part then will be a little bit smaller. But the second part is the most technical part. So, it's, as I said, it's field and laboratory proven. We also had many third-party evaluations and validations. This is only, it's a brief overview of the milestones that we had during the development. So it's not something that was developed within a short period of time, not in a garage. It has been a long process, also with the approval of the technology for the shipping business. Everybody knows the interaction with the class is not so easy and not very fast and takes a lot of time. also some money. So it's really a mature technology today. So as you are all still reading, but maybe I just go over to the next point, if okay. Because most of it, the most important milestones I will present shortly. It's an overview of the partners and the validation institutes and partners. We are working with the DNVGL because on the customer side that is a class doing the approvals. That's a picture of the prototype that was installed inside the M4 Intel. So, and that size of this size could, if we upgrade the pumps and the electrolyzer unit, which has been much developed within the last 3 years, we could feed maybe up to 3 to 5 megawatt with that hardware size. And if you put it into a container, 20 foot, of course, we have a lot of space. So, some impressions from the ship installation. So it was directly placed next to the engine, auxiliary engine. What you see green in the back is a Volvo Penta auxiliary engine with 600 kilowatt. So that was the testing stand. This is a short overview of one of the first testings that we did in real operation on the ship. We had 25% gross savings and about 16% average in net savings. We also did, of course, the emission control and emission monitoring. We had a huge reduction of NOx and COW according to the fuel reduced. This is graphic is showing the improvement of the fuel consumption when the solution was activated. So at that measurement we had about 11.3% in fuel consumption and 66% in NOx reduction. So in this case, we had our system running on 50%. The electrolyzer was running on 50%, so we get a range of what our system is doing. And we had 11.3 gross savings. That is the net balance you see. So we deducted in costs percentage, power, ethanol, methanol, and fresh water that has been used. So at 50% load of our system, in regard to the engine load, we had 8.1% net savings. This is confirming the first test where we had the full load 16%. We also did oil analysis. That is quite interesting. The oil on this engine had to be changed every 500 hours due to lube intake into the oil, fading quality. And after our system was installed, only after several hundred hours, the oil quality improved. So the oil could have been used, it was used for more than 3 times of the original time of 500 hours. So the oil has been used for 1500 hours and was still okay. Not perfect anymore, but still good. So, and as you know better than me, the oil shows the condition, the operating condition of an engine, the inside condition of an engine. That has proven the positive effect of the hydrogen by cleaning almost all residuals, all combustion residuals inside the engine. This has been verified by an inspection of Carl Bagun, which is the Volvo Penta servicing company of the customer. So they opened up the engine, did the inspection as usual, and I've seen no negative effects on the engine, but tremendously reduced soot and residuals of deposits inside the engine. And the engine looked from the inside like new. And of course, visibly less emissions from the exhaust by reducing the black carbon. Yeah, that is a statement out of the inspection report. Cylinders look like new. Here are some pictures, maybe they are more more convincing for you as technicians. For me they look good, but I think you have a different view on that. Yeah, that is what the engine was looking like from the inside after about 500 hours of operating our system. And there's nothing cleaned, it's like it was opened up. We also did laboratory testing, as I already explained. That this has been done on a single cylinder unit at the University of Rostock. Maybe the figures are for you more interesting. Single cylinder was a 60 kilowatt engine. And we tested the working principle, meaning we had no system there, but the oxygen, hydrogen came from bottle, also methanol and water were injected. And we tested it on a huge range of different operation points of the engine, and tested it also to extremes. What is happening when we inject much hydrogen, less hydrogen, only oxygen, in combination with a different ratio of oxygen and hydrogen, also with the water methanol. So for us it was kind of a development boost. We could test many things that we could never have tested on a customer engine. Not really. No.
Did the extrapolation from a single unit to your Volvo Penta unit sort of match?
In the tendencies, yes. In the tendencies, yes, but I really have to admit that all results from real operations on a full engine and electronically controlled engine were every time better than on this manual single cylinder. So for us it was a new testing phase, and we learned a lot about how a single cylinder is operating, but all the tendencies, what the additives and the mixture and the ratio of the additives do were confirmed, yes. So we could test really good what is hydrogen doing alone, in what amount, what is the effect, and so on. It was very useful for us in developing the system, to know what quantities we need to have what results, because we learned that smaller quantities often have the same or sometimes even a better effect than larger quantities, especially oxygen in usage with heavy fuel. We really experienced that small amounts of oxygen are better. So we had to split up the ratio between hydrogen and oxygen to have less oxygen and more hydrogen injected into the engine. Yeah, so we had variation of oxygen mass and hydrogen mass. And we had a fixed set point in the beginning, and so we tested the whole range of different mixtures over this one set point that we set. What has been observed? I mean, this is very technical. I'll come to the conclusion right away. We had reduced diesel consumption, of course. We had nitrogen oxide reduction, reduced filter smoke number, like described in the beginning. We had reduced intake manifold air temperature up to 50 degrees, which of course has very positive effects on the efficiency of the engine. But we also had increased indicated efficiencies. So all the tendencies from the real operation in that regard were confirmed. Not to that extent as in real operation, but as far as we know, there seem to be quite differences in single cylinder operation than in full engines in real operation. For us, most important because it was relevant for the approval, also of the prototype, and of course for future installations, that we had no harm to the engine, meaning no increase in cylinder pressure or combustion pressure. So a brief overview of all the proven benefits that we have, or our conclusions from the real operation experience that we made. We have reduced fuel consumption, drastically reduced emissions, we have reduced wear and tear due to the better operation or cleaner operation or cleaner inside of the engine. We have reduced lube oil costs where it is relevant, and no harm to the operating engine. So the current customer was so satisfied with the prototype installation that they decided to go for a 4-ship installation. That project has already been started in designing and approval, and will start in April. So we hopefully finish the first installation, the first commercial installation in April 2018. 19. Thank you. This again is the conclusion from Carl Babu in Hamburg, the servicing company for that auxiliary Volvo Penta engine. I'll go over this quickly, I think. We have 2 installation options. In ship installation, of course, customized inside, meaning the methanol storage is also located inside the ship. And we have the container solution that you have seen in the video. So now I was a little bit too early. This is the 4-ship project. It's for sister vessels for heavy crane lift ships with a total combined power of 62 megawatt, meaning 12.5 for the main engine and 3 megawatts for the auxiliary engine. And now design is finished for the units, but we're still in the approval process. And what I may say today is, of course, the engine manufacturer had to be involved in the process because we are going for the main engine, for the propulsion engine. And I can say that one of the biggest German manufacturers is supporting the project now. It took some time to convince the people. But they are doing their part of the hazard for the approval process, so we can now really proceed with the support of the engine manufacturer with the installation. That's a question, normally it's the first question we get. The first one is, are you replacing fuel by hydrogen? And the second one is, okay, if it works, what does the engine manufacturer say? So, who's familiar with the general arrangement plans here? Who is the electrical part inside here? Okay, so I can only show the picture. It's a sample installation for one of the 4 ships. I think maybe it's too small anyway. So, it's part of the design. We also, for the same customer, have a container installation for an auxiliary setup. For us, let's say the container prototype version. This will be installed on the MV Paneco, which is a Caribbean ship. And what we have seen in the video is really the actual container. It's real, we build it that way. And this is going to happen also within the next 2 to 3 months. Some more arrangement plans where the container is positioned on the ship, so it's in the back of the ship. So we see the container as the future solution because of the container is more flexible to be used on different ship types. It won't work on every ship type. That is clear, but makes the approval process for us easier on the one hand. Of course, we can improve the cost ratio for the unit, and as I said, we can put all the hardware into one container, so we're very flexible with the container unit to serve almost every ship that is viable to the technology. Of course, we have to validate our savings to the customer, because that is what we promise and what we do. So the hardware that we build is accompanied by a solution that is not our solution, but it's one of the top market solutions in collecting the data that is relevant. Because we experience that most of the shipping customers do not have too much measurement systems. Many don't even have anything at all. So fuel consumption is like this per year. And but as we want to validate also for further development all values from the real operation, we're going to monitor everything, meaning shaft power, meaning fuel consumption of the engine, meaning all operating materials from our system, meaning power consumption of the important parts, and also the trim and the list. All this data is aggregated, and we have real-time operation data then about our system, about the behavior of the main or the optimized engine of the customer, and we can use and provide all this to the customer and use it for further development and optimization of the system according to the engine operation and engine behavior. Of course, you all know what a mass flow, Coriolis mass flow meter is, better than me maybe. So one for the shaft power and one for the fuel consumption, which are the most two important relevant data that we need. Because otherwise, of course, you cannot validate any fuel savings. If you don't have the shaft power or the operation mode of the ship, it gets difficult. Yeah, we're working here with an MRV ready certified solution from MAG. It's also a German supplier. I will go over maybe the methanol aspect quickly. Of course, somewhere in the ship, the methanol storage or methanol compartment has to be installed. We have several options on that, and we already designed several options for several customer inquiries. Until now, we normally found a good location for the methanol department. In void space or in refurbishing one of the existing tanks. Or with the container with a separate methanol tanker or bunker containers. Methanol is actually available everywhere in the world. It's one of the most carried commodities. The only difference for shipping, as methanol is not really used as a fuel in shipping. I think there is only about 7 ships running on methanol. It's available in every port because it's handled and stored in every port. But for the customers, we already have researched the market. It's not a big issue to get the methanol supplied on board. It's delivered via truck, and the price of methanol actually is pretty close to the one of HFO. So there's a direct relation between the two. Nobody knows why, because there's no technical reason for that, but the prices are almost the same. So in our calculation, when we say we're using a pot of methanol instead of heavy fuel, we're always on the safe side to say it's about the same price. The price actually even has become a little bit better than HFO. So it's not too cheap, it's not too expensive, it's cheap, it's available. For us, of course, and the customer is one of the most important aspects of installing the unit. Because methanol is needed, but it's available and not too expensive. The safety concept, of course, is very complex to a certain regard because the DMHL is requiring a lot. We fulfill, because there is no IGF code for methanol, that's why we have to fulfill the IGF code for LNG at the moment. meaning double piped installations, meaning a lot of valves, and of course a control of all processes at all times, and many risk scenarios, more or less real, but that's part of the hazard. So that's part of the safety checks, but it's I won't go through that. Actually, we know what we're doing. The safety setup is where most of our knowledge also is, besides the mixture and the relations of the additives. It has been a long way to go with the class to come to a security concept that is accepted. And it's a really high-level safety system now, taking into account every possible scenario. And to this, the engine manufacturer will also bring some new details, and in the end we have a very secure setup, as secure as possible. We have a controlled process for the project according to leading classification companies like DNVGL. In regard also to the hazard, the design of the unit, and also the support inspection afterwards. I think that's the point where there's a break.
Yeah. So, any questions that? So just one thought. You did a test on the universe trial by injecting hydrogen, oxygen, and methanol at different points, different ratios.
Yeah.
So what was the effect of hydrogen on this? What was the difference
Hydrogen actually is, when you look at hydrogen alone, it's mainly a cleaning component, meaning it is the main factor in reducing NOx as standalone. So on the other hand, oxygen is more pushy. Oxygen, if you have more oxygen in the combustion, you have a pushed combustion process. You push the efficiency, while hydrogen is more on the emission side. And but what is very important, it only works in the mixture of both. If you use hydrogen, because every engine manufacturer has tested hydrogen, of course also oxygen, and they never came to a good result, or not an economic result, because you cannot push the combustion on the one hand very far to get to be more efficient and have fuel savings. On the other hand, you have the problems of increased NOx. If you put in more oxygen, you have higher NOx emissions, so that it doesn't work alone. It is really important to understand that only the combination of the gas component on the left hand for improving the combustion and the cooling component on the other hand lead to positive results on fuel savings and on reducing emissions.
Thanks.
No single component works on its own. It's only really a certain combination of all that lead to good benefits. We have seen that in Rostock also. It can go into every direction. It has to be mixed according to the load level on the engine. Otherwise it won't work well. You can even have negative effects.
I saw the unit. It looks like a compact unit.
Yeah.
The electrolyte, the electrolyzer,
Yeah.
produces the hydrogen, right?
And oxygen, yeah.
Is there like a storage tank for the hydrogen, or is directly fed to the engine?
Every storage of hydrogen, and especially hydrogen, oxygen, even if it's separated, would be a high risk. So we were never allowed to do that, but we also didn't plan to do that, because we really produce the amount of hydrogen or oxygen that we need according to the load level at any time. It always depends on the load level, because the electrolyzer, the reaction time is very fast. So if we have a slip of 1 or 2 seconds, it doesn't matter much. We only produce on demand. There's no storage of hydrogen or oxygen at any time.
Any questions on?
None through from the live team at the moment.
All right. So we'll go to the next part then.
Okay. As we have 5 minutes left, is that correct? Or can we go a little bit into overtime?
Most likely, or
A little bit of scope, but the building closes. We've got to be out around 1:45, I'm afraid. So
all right.
We've got a little bit of time.
Okay, so let's go for the third part. Yeah, this is more the commercial part anyway of the presentation. So we did an analysis with the IMO tool. Maybe you know it. It's an energy efficiency enhancement tool advanced. So it compares several technologies available on certain models of ships and types of ships. So we have done several calculations with that, with our real operation data, with our own experience, and yeah, it seems to be the most cost-efficient technology available at that large scale. I'm not talking about LED lamps, which of course have a very short ROI, but in large scale we have the most economic solution available. Yeah. Just quickly, yeah, it's field tested. It's world's first solution in that way. It's possible to retrofit, and we can guarantee an ROI. That's I think we are the only solution that can really guarantee an ROI to the customer contractually. So that's the most important USP, especially of course for a new technology coming into the market. Of course, we also have side cost reduction when it comes to energy consumption for cooling down, for air intake cooling, which is done electrically. We have already, as described, cost reduction in maintenance and lube oil costs. So in total, we are very confident to guarantee the 10% OPEX savings. Again, this is the net energy balance, because it's maybe it's even the first question of all is, okay, on the one hand you save fuel, but how much methanol do you need? Of course, it wouldn't make sense if you use the same amount or even more methanol than you use on primary fuel. So that's why we always do net saving calculations and really take into account every operating material. The pricing, as described already, is between 60, 80. I was in the euro mindset. So in dollars, it's 80 to 130 per kilowatt. But we only design solutions according to the operation profile. So only if we can guarantee the ROI within 3 years. We wouldn't do any other layout then. We plan to offer 3 different sales models with the customers. The one is a normal purchase, which is very uncommon in shipping business. That is what we have learned. So it will go more into the leasing or BLT model. That's actually where we do the finance for the customer, of course, with partners together. And the third interesting option, risk-free option for customers, is that we only go for a profit share model, meaning the customer is only paying out of his real net savings. Meaning the customer doesn't have any risk, he doesn't have to pay any money, and has a positive cash flow or improved cash flow and operational profits from day one. Of course, large numbers. It's just an example. If you have a customer with 9.5 million US dollars of fuel cost per year, if he saves 10% in total in OPEX regarding to fuel costs, in this case it's a bigger engine of course, and then we have a quite short ROI of 2.7 years. And what we learned, or the feedback from customers, potential customers, is everything up to 3 years is okay. At least it's attractive enough to think about it. Because anything else with longer ROIs and most of the technologies that are available and that are also working and good, they are actually doing something good. they cannot meet the requirements for the economic aspects. They cannot meet the ROI requirements shipping companies have. That's for the greenhouse gas emission reduction potential. I say, due to the lack of time, I'll go through this quickly. Of course, the reduction potential is large, even huge. If the system is installed on many or all ships, we can drastically reduce nitro, NOx, and black carbon. And we can at least do our part for sulfur oxide reduction and saving fossil primary fuel. We have been a bit recognized up till now, a little bit awarded also. So besides the EU funding, we were also shortlisted on the Green Tech Awards in 2017 in Germany, which is one of the bigger, more renowned green technology awards in the world. As a conclusion and summary, the system is funded by the EU. We had a very high score in the SME instrument, one of the highest, or even the highest from that call in 2017. Besides that, it was field and laboratory proven. It's unique and patented, and we think the solution now is hitting the right time, because due to sulfur cap and general discussion about the unhealthy aspects in shipping, or the focus also on cruise ships, is much more awareness than 5 years ago or 10 years ago. So it's the right product to the right time. We have the first customer committed for 4 ships, so it's not only R&D or startup anymore. We're now in the commercialization phase and start to generate traction. And we're positioned quite good for the sulfur cap, because it doesn't matter which way the customers go or the shipping companies decide to go or not to go, our solution can be part of the solution for every customer to reduce emissions and increase profits. So I made it in time, and I thank you very much for your kind attention. And I don't know, maybe if you have more questions at the moment.
Sorry, just on your savings cost there, did you include the lube oil life extension in your savings?
Yeah. When we guarantee the 10% OPEX saving, this is a combination of assumptions.
Okay.
To what extent we reduce the cost. Actually, the lube oil cost is such a tiny amount of the operation. It depends on the engine, I know that, but I learned that there are also systems that recycle the lube oil, so the benefit is a little bit smaller. So, but the 10% OPEX savings is always a combination of net fuel savings, maintenance reduction costs, and the lube oil savings.
How are you approaching the main engine manufacturers then?
As I said, we approached them through the customer side. It was the only option we had. So we're glad to have Harlem & Partner, which is now the owner of the SRL heavy lift company. They're located in Bremen. They have 50 ships. And together with them, we set up the pilot project for 4 ships and approached the engine manufacturer. And it took some time, but we are now in a very...
That's the German manufacturer. What about the Danish one?
It's one of the largest in the world. No, it's the German one. Yeah. It's the German one.
Have you approached the Danish one then, or?
Not yet.
Okay.
But there might be another project where, in not too far away, this will happen. Yeah.
Any more findings online?
No, not online.
All right. Okay. So thanks, Jan, for this very
Thank you.
informative and enlightening presentation. As a token of our appreciation on behalf of the Institute, like to hand over the certificate to you.
Thank you. That's very exciting.
All right. And let's give a big round of applause.